Hey, it's Matthew Todd and welcome to the next lesson in Module 3. In the last lesson, we talked about defining a unit in the context of unit testing. In this lesson, I want to talk about how refactoring can cause the definition of a unit to change. Before the next lesson, we'll look at how testing for purpose can make refactoring much easier and less risky. And therefore, it'll give you the confidence you need to safely do the refactoring that you know you want to, that you should be doing. Which again, if you adopt these principles and practices, will make you one of the best developers in your team. So refactoring. What do we mean by this and why could it affect our units and therefore how we test them? So refactoring is defined as the process of restructuring existing code without changing its behaviour. So it does the same thing as it did before, but it's somehow structured differently. The structure of our code is different. And this could be a very small refactor, where we break up a function into a set of smaller functions. Or perhaps we perform more significant refactoring. Maybe we decide the abstractions that we created for ourselves before no longer hold true knowing what we know now. It could be technologies advanced, meaning we could seek to choose a different type of solution to the same problem. It could be that our understanding of the problem and desired solutions has changed over time, maybe due to new information or the world around us changing. We may decide that we know we want to build on top of an existing solution and need to change the structure in a way to make it more extensible so that we can build on top of it in a cleaner way, rather than just trying to hack something in there. So let's look at a concrete example of when we would want to refactor and talk about how that impacts on our unit testing and our test-driven development. So going back to our calculator TDD demonstration from Module 1, we implemented this in Java and also JavaScript, the very beginnings of a reverse Polish notation calculator. No front end, but the beginnings of the application logic that would sit behind any user interface, behind any presentation. So we started simple, started by thinking about how it's stack-based and how we could build up functionality by starting with the stack-related operations before looking at and implementing the add operation in a test-driven way. So now let's think about what we might want to do if we wanted to build on top of this calculator and support different types of operations. Subtract, multiply, divide are the obvious ones, but there are many more we could come up with, and we could potentially even make our calculator more powerful and allow the client of our calculator class to register their own custom operations. Custom functions you could register with the calculator that could then be invoked based on the values that are on the stack. So looking at the add operation that we have, we can see it's doing a couple of things, and this is evident from the application code we ended up with, but more importantly so, it's evident from the tests that we created. Because we're taking the approach of testing for purpose, we can see that there are a couple of different distinct unique behaviours that are involved in the add operation implementation. So looking at the tests, we can see by taking the TFP approach, we have distinct tests for each of these behaviours. So on returning to our test code, these behaviours are immediately obvious to us. We don't have to go hunting through test method implementations to try and infer these different behaviours based on the assertions we're making. We just look at the tests we have. So we can clearly see that we have the behaviours around how the stack is manipulated, modified as a result of performing an operation, in this case the add operation. We can also see we have an entirely different behaviour, which is about the actual operation, the addition itself. So if we think about adding more operations to our calculator, we could continue with the same approach we use for the add method, where we add more operations in the form of additional methods to our class, subtract, multiply, etc. And we could even follow the exact same implementation pattern and have each operation perform the stack manipulation as well as the calculation. We could choose to factor out some common code. We could choose to split the responsibilities and pursue a solution where the stack manipulation and operation calculation, these two behaviours are separate. So when thinking about performing this refactor, we've also another decision to make. We have to decide what kind of refactor we'd like to perform in order to split out these responsibilities. We could do this in a way that was a refactor that remained internal to the calculator class. We could split out the stack manipulation and actual operations into separate methods or functions, and internally have the calculator class make use of those. Or we could do it in a different way and go for a refactor where the changes are external to the calculator class itself. We could keep the stack manipulation behaviour inside the calculator class and make the operations separate external classes, modules or functions, external to the calculator class. So as we can see, even with a very simple application, there are different levels of refactoring we could choose to apply. in order to make our codebase better. And by better, I mean more flexible, more extensible, easier to change really, to meet a new need that I now have. And this is a decision you have to take based on your context and how your systems need to change right now. So this is all very interesting, but what's this got to do with testing? Well, if we're talking about unit testing still, and working from a point of view where we consider our code structure to reflect our logical units, where we don't have many fake layers and abstractions in our way, then it should be clear that some types of refactoring can change the structure of our code, and therefore the definition of a unit, and therefore following on from that how we should test it. What was a unit previously might not be a unit anymore. So if we're going with the simple refactor of the calculator, where we keep the changes internal to the calculator class, then the code structure, and therefore the definition of the unit hasn't changed. For this kind of refactor, we don't have to change the structure of our tests at all. They can remain exactly as they are, even though the internal structure has changed, and that's the key thing. It's a change that's internal to the unit that we're testing. So remember that testing for purpose isn't coming from an approach where we try and test everything about a unit in a single test method. We test different behaviours of a unit separately in different tests, even within the context of the same method call with the same input. If we were to go with a slightly larger refactor, where we do keep the stack manipulation behaviours inside the calculator class, but we pull out the operations themselves into separate classes, then we have changed the structure of our unit. Thinking about just the case of the add operation, due to the refactor, we would now have two classes, where previously we had one. So we have two units, where there was one before. So this then means our tests have to change as well. And this is where I want to stop for this lesson. In the next lesson, I'll walk through actually performing this refactor, introducing these additional operations, and performing the refactor to pull these out into their own classes or functions. We'll see how taking the approach of testing for purpose and writing the tests actually makes this kind of refactoring much easier to deal with, in a very low risk and actually low effort way. So I'll call out many of the pitfalls that I see people making that make refactoring much harder than it needs to be. So take care, and I look forward to seeing you in the next lesson.